All right, well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap. I'm very excited about this one. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use the question and answer tab there on your interface and submit your questions, and we will try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature, so I do encourage you to chat us your questions, comments, suggestions, whatever you want to share with us. We'll be more than happy to take them, and we might even chat you back. And at the end of today's webinar, we are doing a drawing for 4 $100 Amazon gift cards, so please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is preventing software supply chain attacks in the software development lifecycle. Our speaker today is Josh Bressers, who is the VP of Security at Encore. Josh, thank you so much for joining me today. Really appreciate you being here.
Thank you, Charlene. I am ecstatic to be here on this fine Monday.
Excellent. Well, I know you've got a great presentation on tap, so I'm going to take myself off camera, put myself on mute, and I will be back when we get to the question and answer period.
Awesome. Thank you so much. All right, we'll jump right in and get moving. So today we're going to talk about supply chains, which is a very popular topic for anyone who's been paying attention to the news kind of for the last year or so, I would say. And we'll kind of start out with a little bit of background here, first of all. So obviously, anytime you're talking about security of any manner, you end up with supply chain eventually coming up as part of that. And now the company I work for, Encore, we conducted a study which is in the handout section of this webinar. So by all means, download it and read it and understand it, because it's a fascinating study. But basically, along with this research, we realized that 64% of organizations have experienced a supply chain attack. And that is a mind-boggling number. I mean, that's over half of organizations. And as the arrow of time moves us forward, it's becoming more and more apparent that people are paying more attention to the supply chain, both from the perspective of, the good guys, the developers, the defenders, but also the bad guys. The attackers have realized that the supply chain is a way into an environment, and it's something that we necessarily haven't considered in the past. And so now, as part of this, it also goes without saying that as you shift left, which is a very popular topic these days and always gets a quick soundbite, the idea is that the later in the deployment stage any project or application is, the more expensive it is to solve your security problems. And so the idea is you want to move as much of your prevention as far to the left as you can. I mean, historically, if we look at this world of security, we didn't have a left. It was often you focus on deployment, you focus on your infrastructure, you focus on your runtime. But we're now in this world where we have this opportunity to do more and more during development. Now, if you look on the right side of this graph, we show that there are 570 times, that's a big number, more developers than security practitioners. And this is a really important bit of information, because depending upon who you talk to, there's this prevailing idea of, oh, we'll just shift left and we'll shift all the security people left and we'll do all this work over there. But the reality is there just aren't enough security people. If you try to hire security people in the last year, you know how difficult this is to do. And so the idea isn't that we're going to hire a bunch of security people, we're going to train a bunch of security people, or we're going to turn developers into security people. The reality is that part of what shifting left means is we have to leverage what we have over in development. And we do this through things like tools and process, not necessarily through hiring and creating this huge group of security experts. So here's our quick agenda that we're going to talk about today. Obviously, what is the supply chain? This is something that I think is I want to say it's well understood, but I think there's still sometimes some confusion. We're going to talk about the attacks. We're going to talk about how we prevent them. I love giving actionable, real advice. I detest when security people just complain about what's wrong and then they stop talking. Like that's not what we're doing. And then of course the questions. I love questions. Please ask questions. I'll be very happy. All right. So what is a supply chain, right? So when we talk about supply chains, I think we often focus today on things like the open source we're bringing in, or we might focus on a particular build system we're using, or you might focus on something in our product. And the software supply chain is kind of a newer concept, so we're still understanding some of this. But fundamentally, what we're talking about is it's anything that influences, right? Anything that's part of your supply chain. This goes all the way back to the IDE you're using. It is the computer you're developing on. It is the open source you're including in your project. There's anything that touches the process from going from nothing to a product or project. That is the supply chain. It is huge when you really think about it. It's not one thing. And so I think it's really important that we keep that in mind. That the supply chain is a big thing. Excuse me. All right. So what is an attack on the supply chain now? And this again is where we focus heavily on things like backdoors in open source and vulnerabilities. But it's more than that, because remember, we're talking about everything from the computer you're developing on through the build system, through the packages you install, to even what happens after deployment. So what happens is anywhere along that path, attackers can create problems. And we've got some really nice examples later on where we talk about what some of those problems are and just kind of what we're dealing with and how big this can be. All right. So now when we think about our supply chain risk, right, where is it going to come from? And again, there's a lot of talk about open source right now because I think everyone's figured out how much open source they're actually using. It's a lot. And I think that wasn't well known prior to, probably the last year or two, maybe. Because I think before that, you had developers going to GitHub, going to Stack Overflow, going to using NPM, using whatever package manager, and they were just pulling in what they needed to get their job done. And I understand that. When you're a developer, your job is to develop, not necessarily vet this software or pay attention to what's going on in the security universe. So I'm sensitive to this. So anyway, we've got all these places. And I guess one other important thing at the top of this, it shows vendors. You can buy software from other organizations, and that software becomes part of your supply chain. Like we often think of open source or our own developers, but the people we work with, the organizations we work with are part of this story. And that's hugely important because obviously if something happens to them, they have their own supply chains and it just keeps going. And we kind of show this off here. Excuse me. Everyone has a supply chain, not just us. And so when you're dealing with open source projects have their own supply chain, vendors have their own supply chain. You've got private open source companies that might take open source in and do something with it. I mean, Red Hat's a marvelous example where Red Hat takes open source, they apply that Red Hat magic to it, but obviously that's part of their supply chain. It goes all the way back. And then it gets even weirder when you think about it, because sometimes you've got circular supply chains where this package depends on that package and that package depends on the other, and it goes around in a circle. It's very confusing sometimes. All right. Now, when we are the consumer of the software, we have a unique view sometimes into what we're getting, where we just talked about supply chain and how it goes back and back and back. But if you're working with, say, let's say you build a product and you deliver that product to a customer, this is kind of their view of the product, where they see you as the face of what they're getting, and they don't necessarily know in some instances what's behind what you've done. And so this is one of the modern challenges we have, is trying to unwrap some of this and understand what is behind our supply chain and what can we pay attention to, and even where can some of this risk come from? Because historically, it's been kind of an opaque door where you have the consumers of a software product, the customers in many instances, and they receive a thing from a vendor, And the idea is I'm going to trust my vendor to do what's right. And sometimes that's fair and sometimes it's not. It depends on the vendor. It depends on your situation. It depends what's happening. There's instances where vendors make mistakes. There's instances where vendors ignore problems. There can be instances where vendors do everything right and something still sneaks in. Supply chains are complicated, but it's exciting because we have so much opportunity right now. Okay, so that was probably a little scary. The intent isn't to scare, though. This is actually a marvelous topic, and I think there's a lot of good we can do. So really, it's just about setting the stage. Like, how did we get to where we are today? So I want to start with this. There's this project the Linux Foundation's OpenSSF is working on called Salsa. And Salsa stands for Supply Chain Levels for Software Artifacts. It is a mouthful for sure. But what they've done is this is a picture I took from their website, and I think it does a really nice job of just kind of showing some of the expected stages, an oversimplified picture of your typical software supply chain. And we'll get a little more complicated, but I really like this picture because we can keep it in our minds and we can look at it and understand it and grasp it. And I think the really important part of this is that even though this is very simple, how many of these stages would you say any one team in your organization owns? And the reality is no one team owns probably more than one of these in many instances. And so we like to think historically of a security team owning security and they're responsible for security of everything that happens. And those days are kind of gone. I don't know if they were ever here. I mean, but the point of this picture is to show that everything we do in this supply chain universe is a team effort. There's nothing one group can do. You can't say, hey, security, this is your job to secure this. You can't say, hey, developers, this is your job to secure this. You can't say, IT, you've got to take care of this and make sure we're safe. There's different things we have to worry about every step of the way. And so how we address these are different. I mean, we talk about supply chain as a singular thing, but it's a bunch of little things all put together. And all of them are important. None of them are more or less valuable than any of the others. Now, this is where we'll pull up the big picture, and this is, we'll say, a more comprehensive view of a modern supply chain. Modern supply chains are becoming complicated. Deploying code is becoming complicated. I mean, I'm old, so I remember the day when building a product was typing make on your computer. There were no build systems. There was barely source control in many instances. You might only have a couple developers. Everyone sits together in the same room. So if there's a problem, you can talk to each other. And that's not how it works anymore. Like, this is what we're looking at. There are so many steps and there's so much technology we can apply to each step. And it sounds scary sometimes, but this is good because all of these steps we're using are improving our quality and improving our security when we do it correctly. And that's a big deal because the good old days were not good. They were old, though. And so at the same time, the other important fact of this is there are many things we can do in each of these steps. I mean, this picture is large and maybe a little confusing, but the point is, like, some of the things we can do have a really good return on investment, and some of the things we can do maybe don't. And so I think at this point in understanding supply chain security, what we need to do is start unwrapping some of this and trying to understand what are the things we can do that are going to provide value and what are the things we should maybe not do yet because the technology could be too immature. It could just be not as big of a problem as some other things. There's many things to consider in this. I mean, this is part of the challenge of security is everything we do represents a decision based around risk. And an easy example is if we kind of think of our house, where most of us have houses with a lock on the door, right? That lock is controlled by a little key. And quite frankly, if somebody wants to break into your door, it's not very hard to do. You know, a good kick on most doors is going to get you through. But the reality is we exist in a society where, for the most part, that the risk of that happening is very low. And so we're comfortable having a lock with a key. Now, there are high security environments. If you go to a bank, a bank vault is a marvelous piece of construction. And in fact, at the bank I was talking to the manager one day, and the back wall had a funny, what looked like a strange concrete patch. I was like, what's the deal with that? He said, we locked ourselves out of the vault one time and it took 2 days to get through. So they could, like, basically they drilled a hole through the wall and came in. Like, right? That is not at all. If I get locked out of my house, it takes me 5 minutes to get back in. And so this is just part of that story of supply chain and risk and understanding of where we want to invest and what makes sense. So anyway, here we go. We're going to start out. So the first threat we're going to talk about is something called repository security. Now, when I say repository, most of us probably immediately jump to something like a node package manager, or maybe like Yum or DNF in the RPM world, or apt-get in the Debian world. And that is all correct. That is basically what we're saying, is a repository is somewhere you're going to get an artifact from, an artifact being your bit of software. But it could be Stack Overflow, though. There's GitHub. There's places you can go and maybe not get the traditional artifacts like we like to think about them, be it packages. So the first one is registry or repository poisoning. And this one is really cool. I mean, this can happen with Docker images as well, for example. But basically what this is where you have an attacker gets a hold of a thing, be it a package or maybe a Docker container or something. And what happens is they inject something terrible into it, right? Where it could be malware. That crypto mining is really popular right now, where a lot of attackers inject that. And so what happens is you think you're pulling in something trusted, but it necessarily isn't. And this can be true of GitHub repositories. It can be true of RPMs. It can be true of node packages, whatever. And so this is obviously, from an attacker's perspective, they just have to get their malicious code in, and then it's home free after that. But again, I mean, luckily, there's some things we can do about this. Sorry, I'm too early. So what we do here with repository poisoning is you can sign what you're doing, right? It's an easy way to avoid having a bad guy get a hold of something from after build. But then there's also some things before build. You can monitor what's happening in the infrastructure. You've got many times when open source has an issue, it gets found very quickly, which is very cool because there's lots of people paying attention to what's going on. You can vet what's happening. You can monitor the infrastructure, pay attention to what's happening after you deploy. That's part of the story. There's so much we can do in this space, and we'll cover that in just a moment here. Excuse me. And then there's also something called typo squatting. Now, this one is probably a little newer, and it is a little interesting, I think, compared to some of the other problems. Because what this is when someone misspells a package. For example, you can see like Nginx with 2 X's, Postgres with 2 S's, MySQL with 2 L's. And so what happens here is an attacker basically takes an existing package. For example, in Node, this happens, I would say it gets caught more often. I won't say it happens more often because there's a big difference between an attack and discovering the attack. And just because somewhere like, say, node package managers, more attacks are found, it doesn't mean it has more. It just means they're finding more. So that's also something to really keep in mind. That's what makes this really difficult to untangle sometimes. But anyway, what happens then is an attacker basically takes a legitimate package, they rename it, they add their bad stuff to it, and then they hope people accidentally mistype it. Because let's face it, developers are humans. They make mistakes. They type things in wrong. I mean, how many of us have typoed something when we're typing a command for, apt-get or RPM install or yum install or whatever, right? It happens all the time. And what this attack basically says is you've got an attacker grabbing something, changing it, renaming it, putting it in place and hoping someone finds it. And sometimes they will, sometimes they won't. It just depends. And I mean, one of the lucky things is generally these public repositories have statistics we can look at to understand how many people have downloaded this and things like that. So, okay, how are we going to stop this? And this is where a tool we call SCA, Source Composition Analysis, is really, it's newish, but it does a really good job at catching this. And so what happens is, let's say someone finds a typo squatted package. Let's say someone finds a backdoor package. What happens is that gets an advisory somewhere. Now, I also want to add an important caveat to this is backdoors and typo squatting don't get CVEs. So if you're focused just on the CVE aspect of security, that's not enough. You need to pay attention to other sources of malicious content. Like, for example, GitHub publishes advisories covering these. NPM will publish advisories covering these. So you have to make sure you're getting a diverse set of details, because if you're focusing on just one vulnerability data set, you're going to have gaps in that. So anyway, what happens though is you run a tool that scans your development. It can scan your containers. It can scan your infrastructure. It just depends where you want to deploy it. I would encourage you to deploy it everywhere, because the more you scan, the better. And obviously, it is conceivable something could happen along the way that you might miss at the beginning, but the arrow of time is complicated sometimes. But what happens is the scanner will look at what you've done, and it can identify if there's any known bad packages. And then if there is one, obviously, if you have something like typo squatting or backdoors, you definitely want to stop. You want to have a policy that says, do not let this build happen. Do not let this deploy happen under any circumstances, because anytime an attacker has that level of control over what's happening in your environment, it's going to end very, very badly. And okay. Now we're going to talk about modified artifacts. This is similar to the last one, but it is a little bit different. So what happens with this one is, let's say you build a package, right? And this could be done on, there are instances where these are built on laptops. Sometimes they're built in build systems. The build system could be in an infrastructure you control. There are build systems that exist in public. There are many, many, many places that these build systems can exist. But anyway, and now I should also clarify this. This is also where it gets confusing. So back in the day, when we talked about building software, we would take source code, we would compile it into a binary, and then the binary is what we would deliver. But that doesn't always happen today. If you think about languages like JavaScript or Python or Ruby, those aren't binaries in the traditional sense. What's happening is you're taking the source code and kind of just copying it into a repository. And so that counts as a build though, right? Because we're essentially making something fit for distribution. And so the question becomes, is the thing that was built by whoever built it, be it again a human, a build system, whatever, is that the thing that I'm using? And there was an attack many of us heard of. We often call it SolarWinds, but the actual name is Sunburst. And what happens in this attack was basically there was a build system in the SolarWinds environment that they would build their software. The build system was hijacked. And so the artifact the build system was spitting out was a piece of backdoored software. And so this is one of those instances of like, how do we verify that the thing we're building is the thing we're distributing, or the thing that we're bringing in is the thing that was built? And this one can get dicey because it's not always obvious if something was modified along the way. It's, excuse me, it's easy for us to think about. So I build a thing and then I put a thing out on the internet for people to download, and then people download it. And you'll say things like, oh, I've got a signature that's available, or I've GPG signed it, or checked the source code, or there's many, many things people talk about when it comes to this particular one. And it's a really hard problem. And kind of, I'll skip to this. So I circled provenance on this slide, and provenance sounds really easy, but it's not. And my favorite example of this is, if you look at most software that's been distributed, most open source specifically, I'll say, that's been distributed in probably the last 20 years, a huge amount of it comes with GPG signatures. Now, I'm almost sad I didn't do this, but if I took a poll of all of you right now and asked how many of you check those GPG signatures, the number is probably very low. The poll would probably be high because we all pretend we do. But the reality is, like, checking GPG signatures is really hard. And so provenance is only effective when humans aren't involved. And this is going to be a recurring theme as we go through some of these steps of things we can do, is anytime you're relying on humans, humans get tired, humans make mistakes, humans stay up too late at night, they watch too much TV. There's a million things humans can do. I mean, some of us are phenomenal employees and we have off days. It happens to all of us. None of us are perfect. Robots can be perfect. This is where actually focusing on like the Linux distributions figured this one out a long time ago. If you're using packages from a Linux distribution, they sign those packages by default. And so, for example, if I yum install a package from Fedora or Red Hat or whoever, it's going to check a signature on that package. And if the signature doesn't match, then it's going to not let me install it. It's going to say, hey, something went wrong. The signature doesn't match. And that's huge because now as a human, I can say, oh, holy cow, something went wrong. And things don't go wrong very often. This is rare to see this happen. But the automatic part of this is hugely important because if it's not automated, I'm not going to see it. If I'm expected to download a GPG signature and verify it manually every time, it is not going to happen. Half the time, I'm just going to forget. Half the time, I might be in a rush. There's a million things that can happen. And so the verification is hugely important. And as the supply chain matures, we're going to hear about things like software bill of materials. We're going to hear about when you have a software bill of materials, how do you know it's right? Was it changed? Is this a software bill of materials that I produced and I'm giving to you? How can we show that? How can we verify that the thing I'm putting in my product, like, did I verify those along the way? And so there's all these things that need to happen. And like Salsa is an example of kind of laying out some of the concepts and ideas that can help with this of how do you verify that a project or a company or an organization is verifying those dependencies. And this one's really hard. Provenance, I think, is really important, but we have to be very mindful because putting too much human interaction in this will make it fail. And we do not want to fail. I think this one is really cool and it's really important to get right. All right, vulnerable artifacts. So what do we mean by this one? So I'm going to pick on Heartbleed a little bit here just because I think the whole world knows what it is. But basically what this one kind of comes down to is we're going to pull artifacts from an image repository. And I'm not talking about malware in this instance necessarily. What we're talking about is just vulnerabilities in software. And what I mean by this is, for example, like Heartbleed is the easiest one to understand just because everyone knows what it is. So I pick on it a lot. And basically what happened was OpenSSL created this library that they distribute and is widely used across the internet. And so it was installed on some high percentage of all systems that were basically doing anything anywhere in public. And at some point, they accidentally added a security vulnerability to the library and it was distributed and it was widely used. Now, this isn't malicious. It was an honest mistake by the developers. But what happens is eventually someone finds a problem. And that means now you're shipping a vulnerability. Now, this is an instance where if we were using that source composition analysis type scanner I mentioned a couple slides ago, if you have one of those, your scan will be clean if no one knows about the problem. But now time progresses and all of a sudden your scan isn't necessarily clean. And so this one can be kind of difficult to understand. If we think about the supply chain kind of in two big pieces in this regard, you have the bill of materials, which is the stuff in the product or project or whatever, right? In theory, the bill of materials doesn't change because what is in it is static, right? New versions will have different bill of materials, but the old version has a known collection of artifacts inside of it. Now, if we scan that for vulnerabilities, those can change because I can scan for vulnerabilities today. And at the end of today, a researcher might publish a report of some brand new problems in one of the packages I include, like let's say OpenSSL. And now if I scan it tomorrow, I'm going to get some new findings that weren't necessarily there before. And I think this is one of the other pieces when we talk about automation being important is if you need humans to run your scans, humans get tired, humans forget. There's, we all have horror stories of we had a backup system running on our computers, but we had to run it by hand. And for the first 3 months, we were very diligent at it. And then we started forgetting, and then we just stopped. And then our computer crashes 2 years later, and we think, oh crap, my only backup is 2 years old. And this is kind of a similar story where if we're not running these things automatically, if we're not running these things constantly, what ends up happening is we run a scan, the scan is clean, we say, okay, good, we're done. But the reality is research will happen, time moves forward, and now we could find a problem in something we deployed a long time ago. So this is where having your bill of materials is really important, but then knowing what to do with it is kind of part of the challenge. So a more recent example of this, I would say, is there's this thing called Trojan source, which is a way to hide, we'll say, malicious code. And normally in the English speaking world, we read and write our code from left to right, but there are right to left languages. And so what this does is it takes advantage of Unicode and the ability to kind of switch some sentences around and make your excuse me, make your interpreter or compiler do something unexpected with it, right? And again, this is an instance where, so this wasn't a problem. Someone does research, and now it's something we're going to look for in the future. And Trojan source is especially interesting, I think, because to the best of my knowledge at this point, there has been no successful attack on Trojan source. But that doesn't mean that we should get lazy and say, oh, we don't care about this. It just means it's one of those examples of now we know a new thing and we can apply that knowledge to what we're doing. And so we'll kind of talk about, so how do we stop this, right? And this is where when you have your pipeline, you have everything going on, you have to make decisions about what you're using and how you're going to use them, right? So you can pay attention for strange behavior. You can pay attention for scanning all of your artifacts with what's going on. It's there aren't always simple answers to all of this. So, excuse me. This is where you have to pay attention every step along the way. And I circle image risk here because fundamentally what we're aiming for is understanding what you have is part of that image risk story, where anytime you pull in an artifact, you want to know what's in it, because once you know what's in it, you can pay attention to it, you can scan it in the future. Like, so a really cool example actually is, so you might have a container today. You might scan your container with a composition analysis tool, and it might come back clean, let's say. And now, what do you do in a month? What do you do in a year? Let's say you've destroyed that container a long time ago, and you might say, oh crap, did that contain a version of something way back when? And this is where having a software bill of materials is really cool, because software bill of materials are really small. So you can store them away and keep them for a long time. They're just JSON format. So they're really simple to work with. And so you can store that and then come back later and say, what was in that image? What did I do? Right. But then I guess the other thing, so if we look over on the right side of this one, I also circle some of the runtime protections. So anytime you deploy anything and you're concerned about having vulnerabilities in it, it can be very valuable to have insight into what's going on, because there are also concepts called 0-day vulnerabilities. And what that means is an attacker started attacking a security bug without telling anyone. And that sounds kind of ridiculous when I say it, but what happens in the world of vulnerabilities is you have researchers find things. Researchers will often tell the project or company or whoever, oh, hey, you have a security flaw in this. They will often fix it, and then there will be an announcement where the researcher might want to talk about what they did. The company might want to talk about the fix. You can have, if it's open source, you can't really hide it, so it's going to get checked into GitHub. But these 0-day flaws are basically a bad guy finds a flaw and they start attacking it. And that is a place where runtime is hugely important. And there's, from the perspective of understanding what's in your images and scanning them, like there's nothing you can do because we just don't have that information. It's definitely difficult. All right, we'll keep going. Credentials. This one is always popular because we've all done this more than once. So this one is kind of cool. We all have infrastructure that has to authenticate to each other. And what I mean by this is, like, let's say you have a database. Let's say you have a web application that needs to call to the database. The web application needs to have the ability to authenticate to your database and ask it questions, because the days of just opening everything up and saying it's behind the firewall and having no authentication, those are completely gone. That just isn't a thing any of us do anymore, which is a really good thing. I don't think any of us should ever open infrastructure ever again. I think claiming the firewall will somehow protect us is, I don't know if it was ever true, but it's certainly not true anymore. I think it is one of those situations where you can say it, but it doesn't make it so. Excuse me. So what do we do? How do we store these credentials? And there are some really, I guess, really cool ways to do this now. There's concepts like vault storage, where you can have your, like, for example, web application call to your vault and say, hey, I'm the web app. I'm going to prove to you I'm the web app. Give me the credential for the database, and then you can log into the database. You can store things on disk depending upon what your infrastructure looks like. Sometimes storing things on disk is an easy way to go. You can put things in your environment. If you've worked with containers before, you're very familiar with putting secrets in environment variables, because that's just the easiest way to often get those shoved into your container image. And so what's really interesting about this now is we've got all these credentials, right? We have to do something with them. Sometimes we might put a configuration file in our project, and we've all checked them into GitHub. I mean, I actually looked for a good example of this, of like a major attack, and there's just, I wouldn't say there's any single big one. There's just millions of little ones. And I mean, I've done this more times than I want to admit, where I've had a configuration file, I accidentally check it into GitHub, and then somebody finds it and tells me, thank goodness, it's usually a nice person who informs me of what I've done, and then I can fix it. But there's also some caveats to this that I think aren't always well understood, and I think that makes this problem way more interesting. So let's say you have containers, right? The way a container build works is you'll take your image, you'll do something to it, and then that creates a new image. And then you do something to the new image, and then you do something to the new image. And so you think of containers like this pile of images that all get applied one on top of each other till you get to your application. You can inject credentials in one layer and remove them in another layer, but they're still there because you can look at other images. And this is actually something the bug bounty hunters are catching on to now, is they're looking at container images in public registries that have credentials, but they're not looking in the top layer. They're rolling back a couple layers and looking for credentials in those layers, because sometimes we forget that we can add a credential, do a thing, and then remove the credential, but it doesn't take it away. This is also true of GitHub, where if I accidentally check something into GitHub and then I say, oh crap, I shouldn't have done that, and then I basically remove the line and then check the file in again, there is a history of every commit that has happened in GitHub. And so what happens is people can look at that history and they can find the credentials. So even if it's not, if you do the checkout, you're not going to see it. If you look at the history, it can be there. And so this is what makes this one so tricky sometimes and so difficult. But it's really cool, because this one is actually really easy. When I talk about low-hanging fruit, I think managing credentials is becoming some of the lowest hanging fruit of all, because we'll jump ahead here and start talking about, like, how do we solve this, right? There are secrets vaults. We just talked about this. In those secret vaults, you have the ability to safely store credentials. They have features like they call it break the glass, where if you know you're under attack and you want to just like shut everything down, you can hit a button and no more credentials. Like they don't work. You have instances where, for example, let's say we've got our web server talking to our database. The database could be getting the credentials from the secret store. And so when you break that glass, like, the secret store won't give the database the credentials. It won't give the web server the credentials. Nothing can log in. There's no way for an attack to progress after that, which is very exciting. When you're using a secret vault, you're not writing secrets to disk. So if you don't have to worry about doing things like accidentally checking in a secret, accidentally putting your secret into a container layer. And so these are really cool technologies. And there's a bunch of them now. This is a couple of years ago. I would say secret vaults were kind of new and a little hard to use, but it's come a long way, and they're super valuable and they're super useful. There's also things like composition scanners, like for example, Encore's enterprise scanner. We look for secrets. When you scan a container, when you scan a project, when you scan whatever, it is going to look for known secrets. And if it sees one, it'll tell you. And obviously, like this is one of those instances where if you see a secret in your container, in your application, you're going to want to put a full stop on that. It's not one of those situations where you throw up a warning. No, like that should not leave the door, right? Because if you, again, that concept of shifting left, if we catch credentials before the credentials are supposed to go to the customer or go on the website or go wherever, we just saved ourselves a lot of trouble. Because anytime you leak a credential, you have to rotate the credentials. You have to figure out where they're all being used. You have to make sure that everything gets updated, because as soon as you change the password, something's going to fail, and it's a big headache, and none of us like to do that. And then I also circle compliance on this one. And this is where having internal rules about what you should or shouldn't be doing with your secrets and with your containers is really important. And this is something that I didn't really touch on much in this particular presentation up to this point, but compliance is sometimes seen as kind of the bad guy of security. It's annoying and you have to do this stuff you don't really want to do, but sometimes it can have value. And I think anytime you're dealing with passwords, having reasonable compliance expectations is important. Excuse me. Now, I also want to say one really important part of this is anytime you're a security person and you're setting expectations, especially around something like credentials, because I think passwords are really easy to understand for most of us because we've been doing it for 50 years at this point. But it's really important to set reasonable expectations. You can't say no credentials on disk if you don't have some sort of secret vault somewhere, because if you set your expectations incorrectly, what ends up happening is developers find a way around you. There's that famous picture I'm sure we've all seen of the kind of the gate that goes down in the road, but there's no fence along the side, and everyone just kept driving around the gate because it was easier than pushing the button probably to open the gate. And this is kind of what happens with compliance here. Of if you make it too hard, then people just go around you and they don't do anything. So passwords are definitely a huge part of this. And it's hard though, too. I also want to stress, and this is so important, none of this is easy, and we are in the infancy of so much of this technology. And so by no means feel like a failure or like you don't know what you're doing if it's taking time to sort all this out. This is not simple. This is also, though, we're finding, a trusted partner you can work with to help you answer some questions and just sort through some of these details can be hugely valuable. All right, so let's wrap it all up now. So the first point, we talk about the containers are complex, and it's getting more complex. I mean, when I started, I showed the supply chain, and then we showed kind of the Salsa picture, and then we show the big CI picture that has all the steps and all the stages and all the controls you can use and how we can avoid things and how to stop something. And it is incredibly complex. I know from a personal perspective, it is not uncommon where I will look at some new infrastructure. I'll look at like how AWS is set up somewhere, and I just think this is so beyond my ability level. And I think that's okay. I don't think any of us should feel bad for looking at something in that light, because this is very complicated. We've reached a point where any of our technology is beyond the scope of a single person. When I started my career, I could tell you every computer that was in the ISP I worked for. I could tell you what it did. I could tell you where it literally was in the server room. We don't have server rooms anymore. Nobody knows what's going on in many of these instances. It's just we have the cloud. It's in the cloud. And that's okay. That's okay. That's how progress works. And that's how we move forward. So I know it can be frustrating and I know it can be complicated and scary, but we all feel it. Don't believe anyone who tells you they know all the answers. It's definitely not true. And I mean, that kind of comes to number 2, right? Is supply chain security it's not new. I think talking about it is new. I mean, one of the jokes I always tell is I've been doing security work, product security specifically forever, especially in open source. And like we had the supply chain back in 2005. We didn't know what to call it, but we worked on it. We had open source. We were understanding it. Now it was all bespoke. We had literally humans reading every CVE that was released because it was the only source of vulnerability information at the time. But this is where, as the industry evolves, we have tooling that's coming with it, and the tooling is getting really exciting and really interesting. I mean, this is one of the things. This is one of the reasons I was excited to work with Encore. Is when I look at where the tooling is today versus where it was even a year or two ago, it is becoming a compelling story, and it's becoming really impressive, and it's becoming useful, which is awesome, because there's nothing more frustrating to all of us than having a bunch of tools we can't use. We've all been there. I mean, I have a wood shop in my garage. It's full of tools I don't use. And I think IT is no different, where there are tools that are valuable to us and there's tools that aren't. And I think from the supply chain perspective, these tools are becoming very valuable, and I'm very excited for the future there. And then number three is what are you going to invest in? What's the low hanging fruit? And I can't answer this. I wish I could tell you what the things are you should be focusing on, but every organization is different, and every person is different, and our expertise is different. And so this is one of those things that you have to look at all of this information, and you have to decide, what is the thing I can do that will have the most impact? And that is a hard question to answer, because when we're talking about risk, there's no single answer. You can say, if I do this, then you're never going to get rid of problems. You just have to think, like, if I do this thing, if I invest over here, what does it mean later? Is it going to make it harder for me to accidentally install a malicious package? Is it going to make the product I'm shipping safer for customers? Is it going to make my developers work faster? And I mean, that's part of it too, right? Is like, some of these things we do can help developers. There are literally millions of packages in these repositories. How do they pick? Are there tools we can use to help them pick? And then, I mean, that folds right into number 4. Then, the last point is just, one person can't do it. This is a team effort. We're all in this together. And I know that's kind of a hokey way to end, but it's completely true. This is extremely complicated, and you can't do it all. There's the legendary security teams of the days of yore showing up and saying, I'm the security team, I'm in charge of security, stay off my turf. That doesn't exist. I mean, if you're a security person and you think like that, like, I got bad news for you. It's I don't think it existed back then, but it certainly doesn't exist now. And so, yeah, it's just, this is hard. This is complicated. Like, don't feel bad. Ask questions. That's part of how this all works. If we know we're working together, we can ask each other questions and we can all learn more. So, all right, we will move on to the Q&A. I want to thank everyone for listening. That was a ton of fun. Thank you so very much.
Lots of great takeaways too. So, and we have gotten a ton of questions in, so I hope you are ready, Josh. But there's still time, guys. If you have a question for Josh, please go ahead and use that question and answer tab and get it on in. And hopefully we'll be able to get to it. Like I said, we've gotten a ton of them in so far, but don't let that stop you. Go ahead and get your question in. The first question is from William. He asks, could you share your thoughts on protecting the integrity of code by enforcing strong version control policies using artifact repositories? And I know you did kind of go over that a little bit, but maybe you can kind of expand on it a little bit.
Yeah, absolutely. I mean, I think the artifact repositories are marvelous. I think they provide a lot of value for a couple of reasons. And there's the integrity aspect from, is the code I'm using today going to disappear? And there's a story in the Node ecosystem. I pick on Node a lot. I love Node. Please don't think I'm looking down on them. I am very familiar with them, so I use them as my examples. But there was, I think it was called LeftPad was the name of the package, and the developer got angry and just deleted it. And all of a sudden, everything broke. But if you're using your kind of private repository, then that solves that problem, right? So I think that's a huge deal. But then there's also kind of the aspect of versioning and managing your own things. And yeah, I think what I would say in that instance is, this is where things like using SBOMs are valuable, because now you can catalog what you have, you can understand the exact versions, and then you can go back and look at that later if you need to. I hope that answers the question.
All right, great. The next question here is from Steve. He said, SCA is good for open source. In general, will requiring such as SSL certificate with digital signature for update server mitigate the risk like SolarWinds, which somehow bypass multi-factor authentication?
Okay, I think that's two questions. I'm gonna treat it as two.
Okay.
So the first one is
All right.
SCA is open source, and yes, that's absolutely correct. Today, SCA is heavily focused on open source, but I think the reason for that is open source is where we can find essentially software bill of materials, because you can look at a Git repo, you can look at the package as it's delivered, whatever, and you can understand what's in it and you can pick it apart. There is movement happening in the just, I guess, all industries now of software bill of materials being required for all products. And so what's going to happen, I think, is once you have a software bill of materials from, say, a vendor that's not open source, now you can feed that software bill of materials into your SCA scanners and you can start doing more with it, and you can pay attention to the non-open source things you have. Now, this is a ways away. So like, to my knowledge, there's no way to do this today, but I think the rest of the industry is catching up with what open source has accidentally done. And then I think the second part of that was about signatures and SolarWinds, and like could signing the software have helped? And in some instances, yes, absolutely. In the particular instance of SolarWinds, they did sign the package, which also contained malware. So that's a slightly different problem. And I won't dwell on it at the moment because it's very, very complicated. It's just the easy example everyone can understand is kind of why I threw it in there. So I'll say you kind of got me on that one.
All right. All right. Still plenty of time to get your questions in. So if you do have a question for Josh, just go ahead and use the question and answer tab there on your interface. Robin actually has a similar question. Hopefully kind of continues the conversation. I noticed that the SCA vendors are focusing solely on open source components. What's the best way to manage similar risks for commercial components?
I mean, I think the the current way to do it is, first of all, you have to acknowledge that everything is full of open source, right? So if you're working with a closed source vendor and they're giving you a product, it definitely has open source in it. So I think you can go looking for it. There are tools that let you kind of pry some of this open and peek. You can ask them for a bill of materials. Say, I want a list of all the open source in your product. And that, I mean, that might have been unreasonable a couple of years ago, but like the Biden executive order that came out, a couple months ago, literally says you have to do this. So this is not becoming an unreasonable request. And then I think additionally, just as we go forward, I think telling people what's in their product is going to become the norm. I mean, think of it like food labels are kind of the example everyone uses, where 100+ years ago, no one labeled the food because they didn't want you to know what was in it because it was terrible. And now, like, it's federal law. You can't not tell people what's in the food they're buying. And I think software is going to follow that path of it's just going to become normal. So I would say for the moment, ask your vendor. They might say no, and there's probably not a lot you can do about it. But I do think the change is coming. I truly believe that.
All right, great. We have an interesting question here from Paul, who asks, from the bird's eye view, are supply chain attack methods on software dev cycles evolving faster than the tools or social engineering required to mitigate their effects?
I think about this every day. And I think it is a complicated problem. I think anytime you're in the position of the defender, by definition, defenders have to defend. So we can't defend until there is an attack. We can guess sometimes where we might do something that we think will matter in the future, and sometimes we get it right, sometimes we don't. But fundamentally, I think we have to wait to see what the attackers are going to do, and then we can respond to them appropriately. And do I think they're evolving faster? I mean, I don't think they are. I think it feels like it sometimes because there's that tick and tock that's constantly happening, where I think probably the last 6 months really felt intense, where there was all this pressure because there were all these attacks and there was all this coming out. And I think part of it is just because of all the tooling, we're learning more. And part of it is I think we might have just been in a perfect storm of attacks. But I feel like now, like today, it feels less just dangerous. I might almost say. I feel like things are calming down a little bit, and so I think now is when the tooling can catch up. Now is when the defenders can catch up. So I will never stop thinking about this, but I'm so far optimistic that they aren't going to outpace us.
All right, then. Well, we are about 6 minutes to the top of the hour. I think we have time for one, maybe two more questions. So, William actually has another question. The dev environment tends to be a bit of a Wild West when it comes to privileges. How can organizations secure the operating environment for software engineers by governing access to resources using principles of least privilege and a zero trust security model?
Yeah, I mean, that's a great question. That's a tough one because developers need to develop, right? I mean, that's kind of how this works. And if you restrict them, it can be harder to do their job. And so I think, I mean, you mentioned zero trust in part of your question. And I think that's part of the answer is the days of having to lock down systems with lots of passwords and encryption keys and things like that. Zero trust helps with a lot of that. I think part of the answer is deploying some of the tooling we've been talking about, where you can maybe leave your developers a little more Wild West, but then now that we have this pipeline that doesn't go developer straight into customer, now you can build and test and deploy and things like that. And so maybe along the way, think of it as like kind of narrowing the funnel with respect to how many permissions you might be granting along the way. And obviously, when you get to the end, you want it to be as small as possible. And this is, again, where tooling can help, where you can, for example, have tests that are running that are looking for your application doing dumb stuff. You know, if you have an application that's, say, writing and reading files in a weird directory, you can pick that up right away now. It's not like it used to be where it was maybe impossible. And part of this too is, yes, this is a problem and we don't have all the answers. So I think it is getting better. I look at today versus 1 or 2 years ago, and I would say it's drastically better in many instances, and it's going to improve.
All right, great. Let's do one final question, then we'll close out the question and answer period.
Awesome.
Alexander is asking, does Encore have the ability to check transitive open source libraries in used internal libraries?
I think I understand what that means, but if I don't, maybe just hit me up on Twitter or something later. But so I believe what's being asked is, so there's this concept called transitive libraries. And what that means is you, for example, let's say I depend on OpenSSL and OpenSSL depends on, we'll say glibc. It depends on lots of stuff, but I can't think of anything else, right? And so glibc is like that transitive dependency. And so sometimes when you scan something, you only get the first layer behind it. It was like I showed a slide way at the beginning that was like turtles all the way down, kind of. And so, like, can Encore specifically do this? Yes, it can. And we actually have 2 open source tools called Sift and Gripe. I'd highly suggest you go take a peek at them. You can just use them. There's an open source project, patch is welcome. But what they do is they will look at your, like, for example, if you scan a container, they will look at what's actually in the container. They don't just like look at, say, the dependency list that comes with, say, your project, where like you have like packages.json and node. It traverses into the directories and sees what's there. But I mean, that's a great question, because if you're only scanning the first layer, you're missing thousands of dependencies. I mean, a node application, you might have 10 dependencies that you depend on, and there could be 1,300 dependencies behind those. So yeah, that's really good. Really, really good. Thank you.
Awesome. All right. Well, we are 2 minutes to the top of the hour. So unfortunately, that is all the time that we have for question and answer period. I do want to thank everybody who did submit questions. They were really good ones. And if we didn't get to your question, please know that Josh is going to get a copy of all the questions that came in. So I'm sure he or somebody from his organization will be more than happy to follow up with you offline to get your question answered. Also, a quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email after today's event that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can go look for it there. Just go to devops.com/webinars, look in the on-demand section. It should be right there waiting for you. All right, real quick, before we shut things down, let's go ahead and do the drawing for the 4 $100 Amazon gift cards, just in time for the holidays. Our first winner today is Anthony A. Congratulations, Anthony. Our second winner today is Jessica C. Congratulations, Jessica. Our third winner today is Jack L. Congratulations, Jack. And our fourth and final winner today is William V. Congratulations, William. We'll be following up with all four of you offline by email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam folder. Josh, thanks so much for a great presentation. Lots and lots of great takeaways. I do appreciate it. And judging from the number of questions that we got from the audience, they dug it too. So thank you so much.
No, thank you. Thank everyone. This was amazing. It was so much fun. I had a blast.
Awesome. Well, we'll have to have you back another time to talk.
Absolutely.
All right, great. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.